Look at some more examples on squeeze theorem. I'm going to go ahead and erase this one. Let's say we have a question given like this. Limit x approaches 0, x sine x. Okay, now for this one, what we do is we can just look at the sine x graph first. If you look at the sine x graph, it looks like this. It goes up and down, and it has a horizontal asymptote at x is equal to 1, and also it has a horizontal asymptote at x is equal to -1. Actually, y is equal to 1. Okay, horizontal asymptote at y is equal to 1, horizontal asymptote at y is equal to -1. So from this one, we know that the y value should be between 1 and -1. So we can say the sine x function, not y value, actually sine x function, because our y value is x sine x, but we are just looking at the sine x function. So sine x should be always between -1 and 1. So we can express that one like this. -1 is less than or equal to sine x, that is less than or equal to 1. Okay, now what we are going to do is we are going to multiply this one by x. If we do that, this is going to become -x, x sine x. -x is less than or equal to x sine x, less than or equal to x. Now we are interested in this. This is our question given here, right? This is our question. We are interested in finding out this. So to find out this, what you can do is we can take the limit separately. Like you can take the limit x approaches infinity, and you can find out what is the negative x. When x approaches 0, you can find out what's the negative x is. 0 and negative x. And if you plug 0 for the x value, this is 0. And you can find out what is the limit x approaches 0, x values. And if you plug in 0 for x, that's also 0. So from this one, you know that we have negative x is 0, so this one is 0, and then x sine x remains the same. X is also 0. So according to squeeze theorem, this one must be 0 as well. So the answer is 0. But you can express this one in a whole thing in one equation. Like let's see how we can express everything in one term. I mean one equation. To do that, I'm going to go ahead and erase this one. Let's erase these things as well. I'm going to need a bigger space for that. Okay, let's go. So the expression of whole thing in one is going to be like this. Limit x approaches 0, and then we put the negative x. That is less than or equal to limit x approaches 0, x sine x, and that is less than or equal to limit x approaches 0, x. Before we did one by one, here we are doing everything together. So from this one, you know that if you substitute 0 for the negative x, that's going to be 0, and that is less than or equal to limit x approaches 0, x sine x, and that is less than or equal to, if you substitute 0 for the x value, this is also 0. So we are having this given function between 0 and 0, so therefore this must be 0. That's why we are getting the answer 0. Now let's look at another problem. Let's say we have a function given like this. I'm going to go ahead and erase this one first. Okay, so let's say we have a function given like this. Limit x approaches 0, x cubed cosine 1 over x. How can we solve this? So first, if we look at cos 1 over x, and if you draw the graph of that one look like this. That's exactly like sine graph. Okay, and the horizontal asymptote is at 1 and -1. Y is equal to 1, y is equal to -1. So from this one we can express the function express this one like -1 is less than or equal to cos 1 over x less than or equal to 1, because this value must be in between 1 and -1. That's why we express it like this. And now we look at our given question. The question is x cubed cos 1 over x. So we have to, if we multiply this one with x cube, we are going to get the same expression, so we can find the answer. So to get that, I multiply this one by x cube, so we are going to get -x cube less than or equal to cosine 1 over x less than or equal to x cube. Now from this one we can go ahead and solve it. So first let's take the negative. I'm going to go ahead and write everything in one term so you can see it clearly. So limit x approaches 0. First we have -x cube. I write this one right here, and that is less than or equal to limit x approaches 0, that is cosine 1 over x, and then less than or equal to limit x approaches 0 x cube. Now first if we plug 0, we can do the direct substitution for the first one. If we plug 0 for the x value, that is 0. So 0 is less than or equal to limit x approaches 0 cosine of 1 over x, and that is less than or equal to, here also we can do the direct substitution. If we do that, this becomes 0 as well. So 0, and the given function, this is our, and don't forget to put the x cube. Okay, this one x cube, and here also this one x cube, because we multiply by x cube. So the given function is x cube cosine 1 over x is less than 0, also like less than or equal to 0, also greater than or equal to 0. So therefore this one must be 0 as well. So the answer is 0 for this one. And that's it for this video, guys. Thanks for watching. See you guys on my next video.